Welcome to my channel. Here you'll find videos for listening practice, for learning English on your own.
Okay. System design. You know system design. You've done system design. Horizontal scaling, vertical scaling, load balancers, caching layers, database replication. You know all of this. You've built this stuff. You literally built a distributed cache at your last job. Right. And behavioral questions. Tell me about a time you disagreed with a technical decision. Tell me about a time you had to work under pressure. Tell me about literally every difficult thing that has ever happened to you, formatted as a star response. Situation, task, action, result. Situation, task, action. God, I hate this format. It makes everything sound like a case study. Well, in Q3 of my previous role, I strategically leveraged cross-functional synergies to, no, that's terrible. Just talk like a human being. Okay, the company. FieldPath Technologies, Series B startup, about 230 employees, raised $45 million last year. They build developer tooling, infrastructure monitoring, observability platform. Competitors are Datadog, New Relic, Grafana Cloud. Their differentiator is AI-powered anomaly detection with sub-second alerting at scale. Okay, so they care about performance. They care about low latency. They care about handling enormous amounts of telemetry data. If they ask me a system design question, it's going to be something in that space. Design a metrics ingestion pipeline. Design an alerting system. Design a time series database. I should be ready for all of those. Oh, calendar reminder. HR screen with Priya, 9 a.m. That's in 22 minutes. I should probably eat something. I should probably also put on a shirt that isn't wrinkled. Okay, Jamie, you've been doing this for 8 years. You are good at this. You are qualified for this role. You want this job. You can do this. You can absolutely do this. This has been sitting here for 40 minutes. Good morning, Jamie. Can you hear me okay? Sometimes the connection does this thing where... Yeah, no, I can hear you perfectly. Good morning. Great. Okay, so I'm Priya. I'm on the People Operations team here at FieldPath. I handle the early stages of the hiring process for the engineering org. This call today is about 30 minutes, give or take. Pretty low-key. I just want to get a sense of your background, make sure we're aligned on the role and what you're looking for, and then if everything looks good, we'll move you into the technical rounds. Does that work? Absolutely, yeah, that sounds perfect. Awesome. So, and I always say this up front because I think it's only fair. I'm not going to quiz you on technical stuff. That's not my world. I will leave that to Marcus and Elena, who are significantly more qualified than I am to make your life difficult in that department. Good to know. So let's just start simply. Tell me a little bit about where you are right now, what you're doing, and what brought you to look at FieldPath specifically. Sure. So I've been at Corvin Systems for about 3 years. I'm a software engineer there, working on their data infrastructure team. We handle the back-end pipelines for a pretty large-scale analytics product, so a lot of what I do is around data ingestion, processing, storage, making sure things are fast and reliable at scale. It's been a great experience. I've learned a ton, but I'm at a point where I want to work on something that's a bit more directly in the developer tool space. Like, I've always been more interested in tooling that other engineers use than in, say, consumer-facing products. Interesting. And what specifically drew you to FieldPath? Because we get a lot of applicants who say, I love developer tools, and then they haven't really looked at what we actually do. Yeah, no, I did actually do my homework on that. I've been following the observability space for a while, and honestly, what caught my attention about FieldPath was the anomaly detection angle. The approach of using ML to reduce alert fatigue. That's a real problem. I've been on teams that were just completely overwhelmed with alerts, half of them false positives, and people just start ignoring them, which is obviously dangerous. So the fact that you're trying to solve that specific pain point resonated with me. That's a good answer. Okay, so current situation. Are you actively interviewing elsewhere, or is this more exploratory? I'm actively looking, yeah. I have a few conversations going, but nothing in late stages. And what's your timeline? Like, when would you need a decision by, or when could you realistically start? I'd want to give my current employer 4 weeks' notice. I think that's the right thing to do. So realistically, I could start about a month after an offer. I'm not in a rush, but I'm also not going to drag this out indefinitely. That's totally reasonable. Okay, and I always want to get this out of the way early because I hate it when it becomes a surprise at the end. Compensation expectations. The role is posted at a range of 140 to 170 base, depending on experience and level. Does that range work for you? Yeah, that range works. I'd be targeting the upper end of that given my experience level, but I'm flexible. Good to know, and that's completely fair. Okay, so the process here, if you move forward. After this, the next step is a technical interview with 2 engineers from the team. That's Marcus and Eleanor. That's a 2-hour block, and it has 2 parts, a live coding section and a system design conversation. Then, assuming that goes well, you'd meet with Derek, who's the hiring manager. He runs the infrastructure platform team. That conversation is more about fit and direction. It's a bit more open-ended. And then a decision usually comes within a week of the final round. That's a pretty clean process, actually. A lot of companies make it much longer. Yeah, Derek is really intentional about not dragging people through 8 rounds of interviews. He has opinions about that. Okay, a couple more quick things from me. Can you talk to me about a moment in your career where something went wrong and you had to figure it out? Yeah, of course. So, about 18 months ago, we had a production incident at Corvin. A deployment went out on a Friday afternoon. Yes, Friday afternoon, I know. And it introduced a memory leak in one of our core ingestion services. We didn't catch it immediately because the symptoms were gradual. The service just got slower and slower over about 3 hours until it started dropping messages. By the time we were paged, we'd lost about 40 minutes of data, which for an analytics product is significant. What did you do? First thing I did was roll back the deployment. That was straightforward. Then I spent the next several hours going through logs trying to understand why our monitoring hadn't caught the gradual memory increase earlier. And the honest answer was that our alerting thresholds were set up to catch sudden spikes, not gradual degradation. So we had a gap. I wrote up a post-mortem, we adjusted the alerting strategy, and I also pushed for us to add circuit breakers to that service, so that if memory usage crossed a threshold, it would restart gracefully before dropping messages. And did it work? Has it happened since? We've had the memory leak pattern surface twice since then in other services, and both times the circuit breaker caught it and recovered automatically without any data loss. So, yeah, it worked. That's a really solid example, and I notice you said I pushed for. Was there resistance to implementing those changes? There was some. My tech lead at the time was worried about the operational overhead of adding circuit breakers everywhere, which is a fair concern. I had to put together a pretty detailed proposal showing the failure modes and the cost of the alternative, which was basically, we just hope this doesn't happen again. That was a useful conversation to have. Okay, I really like that. I think that's most of what I wanted to cover. Is there anything you want to ask me at this stage? A couple of things, yeah. What does the team look like right now? The infrastructure platform team? Size? Makeup? So it's Derek's team. There are currently 8 engineers, mix of senior and mid-level, 1 principal engineer. It's a relatively flat team. Derek is not a micromanager, I'll say that much. That's good to hear. And what's the remote situation? Hybrid. The expectation is 2 days a week in the San Francisco office. If you're not in the Bay Area, we'd need to talk about relocation, but I see from your profile you're in Oakland, so you're good. Yeah, that works fine for me. Great. Okay, I think we're in good shape. I'm going to send you a note by end of day today, confirming next steps. I feel good about this conversation. I think the technical round will be really interesting for you, honestly. Marcus and Eleanor are both excellent. That's both reassuring and slightly terrifying. That's the appropriate reaction. Good luck, Jamie. Talk soon. Thanks, Priya. Really appreciate it. Jamie, hi, welcome. I'm Elena. I'm a senior, mid-level engineer on Derek's team. I've been here about 2 years. Marcus, senior engineer, 8 years at Fieldpath. Great to meet you both. I'm excited excited might be a generous word. I'm ready. Let's go with ready. I appreciate the honesty. Okay, so do you want to walk Jamie through the format, Marcus, or should I? Go ahead. Okay, so 2 parts today. First 45 minutes or so is a coding exercise. We'll have you work in this shared editor here. You can see it on your screen. It's a collaborative environment, so we can both see what you're writing as you write it. The second half is system design. More open-ended, we'll have a whiteboard component. Throughout both parts, we really want you to think out loud, like actively. We're more interested in how you approach a problem than whether you land on the perfect answer. We're not looking for you to recite answers from a prep book. Noted. Okay. Coding question. You have a stream of events coming in. Each event has a timestamp and an integer value. You need to implement a class that, at any point in time, can return the average value of all events in the last n seconds. The stream is not necessarily in order. Events can arrive out of sequence. How do you approach this? Okay, so first question for you. When you say last n seconds, do you mean a sliding window relative to the current wall clock time or relative to the most recent event timestamp in the stream? Good question. Most recent event timestamp. Okay, that simplifies things. And n. Is it fixed at instantiation or can it change? Fixed at instantiation. All right, so my first instinct is a sorted data structure. I want to be able to efficiently find and remove events that fall outside the window. If I just use a list and scan it every time someone calls the average, that's ON per query, and the list grows unboundedly, which is bad. If I use something like a sorted D key or a min heap ordered by timestamp, I can maintain the window efficiently. Can you say more about the D key approach? How does insertion work if events are out of order? Right, so a dequeuing is normally nice because you push to the back and pop from the front, and that works great if your stream is in order. But if events arrive out of order, I can't just push to the back because I might get a timestamp that's earlier than something already in the D key. So a plain D key breaks down. So I'd lean toward a sorted list or a heap. If I use a min heap ordered by timestamp, insertion is O log n, and I can lazily remove expired events, meaning I only clean up the front of the heap when I'm computing the average, not on every insertion. The trade-off there is that my average function might be slower in the worst case if I have a big backlog of expired entries. What's the time complexity of your average function in the worst case? Worst case is OK log n, where k is the number of expired entries I'm removing, which is not great if you have a lot of late-arriving old events. Can you do better? I could keep a running sum. If I maintain a running sum alongside the heap, I don't have to iterate over all valid events to compute the average. I just divide the running sum by the count of valid events. That makes the average call OK log n for the cleanup part, but the computation itself is O1 once the heap is clean. How do you handle the running sum when you remove expired events? I subtract their values from the running sum as I pop them off the heap. So every time I call the average function, I pop from the heap until the front element is within the window, subtracting those values from the running sum as I go. Then divide sum by count. What's your count? I'd keep a separate counter. Increment on insertion, decrement when I pop an expired event. Okay, let me just sketch this out. Yeah, that looks right so far. What class are you calling it? I'll call it streaming average, and it takes n in the constructor. So, init to self n, initialize self, dot n equals n, self heap equals min heap, self, running sum equals 0, self count equals 0. And I'll also keep self max timestamp equals 0, so I know what the current window boundary is. Why do you need max timestamp separately? Couldn't you just look at the top of the heap? The heap is a min heap ordered by timestamp, so the top of the heap is the oldest event, not the newest. I need to know the most recent timestamp to define the window boundary. I could use a separate max heap for that, but that feels like overkill. Just tracking a variable is cleaner. Fine. Talk us through the add function as you write it. So, add self timestamp value. First, update max timestamp if this is a newer event. Then push the tuple timestamp value onto the heap. Then add value to running sum and increment count. I'm not cleaning up expired events on insertion. I'll do that lazily. Why lazily? Because if I clean up on every insertion, I'm doing O log n work per insert just to maintain the heap anyway, and then doing more work on top of that to purge expired entries. Lazy cleanup amortizes the cost. The total number of pops across all operations is bounded by the total number of pushes, so the amortized cost per operation is still O log n. Okay. What does the average function look like? So, average, self. First I call a cleanup helper. Let's call it evict. That pops from the heap while the top element's timestamp is less than max timestamp minus n. Subtract its value from running sum, decrement count. Then return running sum divided by count. And I should handle the edge case where count is 0. What do you return if there are no valid events? I'd probably return none or raise a value error. Depends on the contract. I'd ask the caller what they expect. For now, I'll return none. There's a bug. Okay, where? Look at your eviction condition. I'm checking the condition. I have heapleters, max timestamp, self.n. That should be... Oh, I see it. The boundary should be less than or equal to max timestamp, self.n, not strictly less than. If an event arrives at exactly the boundary timestamp, it should be evicted, or actually, wait. It depends on whether the window is inclusive or exclusive. If the window is last n seconds, does that include the event at exactly n seconds ago? What do you think it should be? I think it depends on the use case. If someone asks, give me the average of events in the last 5 seconds, I'd intuitively include the event at exactly 5 seconds ago. So the window would be events with timestamp greater than or equal to max timestamp n, which means I should evict events with timestamp strictly less than that. So my condition is actually correct. Or, wait, let me reread what I wrote. I have heaplamor, or isi I say, max timestamp and self.n. That evicts events strictly older than n seconds. That means I'm keeping events that are exactly at the boundary, which is inclusive. So that is correct for the inclusive interpretation. Was that actually a bug, or were you testing me? Both. The code looks good to me, Jamie. I think what Marcus was probing at was whether you'd thought through the boundary condition, not necessarily that your code was wrong. It was ambiguous. The boundary condition was ambiguous, and you didn't explicitly state your assumption. That's fair. I should have stated the inclusive-exclusive choice up front. Lesson taken. Okay, let's move to system design. I'll kick this one off. So, you're building a metrics ingestion pipeline. Think about what FieldPath does. We're receiving telemetry data from thousands of customer services. Metrics: CPU, memory, request latency, error rates, custom application metrics. The data comes in at roughly 5 million data points per second at peak load. You need to ingest it, store it in a way that supports fast queries, and support real-time alerting. How do you design this system? Okay, 5 million data points per second that's significant. Let me think about what a data point looks like first. It's probably a timestamp, a metric name, a set of tags or labels, and a numeric value. So something like timestamp, metric name, a tags dictionary, and a float value. That's exactly right, yeah. Okay, so at 5 million per second, if each data point is, say, 100 bytes, that's 500 megabytes per second of inbound data. That's not trivial. You cannot ingest that directly into a database. You need a buffer layer. I'd start with an ingestion tier. Clients write to a fleet of ingestion API servers. These are stateless, horizontally scalable. They accept the data, do basic validation, maybe some light enrichment, like adding a received at timestamp, and immediately write to a message queue. I'd use something like Kafka here because you need high throughput, fault tolerance, and the ability to replay data if something downstream fails. Why Kafka specifically? Why not Kinesis or Pulsar? Fair question. Kinesis is a reasonable alternative and has the advantage of being fully managed, which reduces operational burden. My preference for Kafka in this scenario is retention flexibility. Kafka lets you keep data for long periods and replay from any offset, which is useful for the alerting use case where you might want to backfill. Pulsar is also strong, particularly for geo-replication. But honestly, the right choice depends on what your team has operational expertise in. If your team knows Kinesis, use Kinesis. Okay, continue. So, from Kafka, I have two downstream consumers. First is the storage consumer. This reads from Kafka and writes to a time series database. For time series data at this scale, I'd strongly consider something like ClickHouse, Timescale DB, or InfluxDB IOX. Essentially, a columnar store optimized for time-based range queries. The key design choice here is how you structure the data. You want to be able to query, give me all values of metric X for host Y over the last hour efficiently. That means your partitioning strategy matters a lot. I'd partition by metric name and time bucket, maybe hourly or daily, depending on query patterns. What about cardinality? Customers can define custom tags, which means tag combinations are essentially unbounded. Yeah, that's the classic high cardinality problem in time series databases. It's actually one of the hardest things to get right. If you naively create a separate series for every unique tag combination, your index explodes and query performance tanks. Approaches I've seen work. One is to store tags in a separate metadata index, like an inverted index or a columnar structure, and keep the raw metric data in a flat append-only table, indexed only by time and a series ID. You look up series IDs using the tag index, then fetch the raw data by those IDs. That decouples the cardinality problem from the hot query path. Another approach is to limit the cardinality at ingestion. Reject or drop metrics that exceed a certain number of unique tag values per metric name. That's aggressive, but some systems do it. What are the trade-offs of the first approach? The metadata index becomes a potential bottleneck. If you have very high write rates for new tag combinations, the index can get hammered. You also have a join-like operation at query time between the metadata index and the raw data, which adds latency. The mitigation is caching the series ID lookup results aggressively. Most queries are for metrics you've seen before. How do you handle late-arriving data in your write path? So, late-arriving data, events that have a timestamp significantly in the past. This is tricky for columnar append-only stores because they're optimized for sequential writes. If you allow arbitrary writes to pass time buckets, you're essentially forcing random writes across your storage, which destroys your I/O patterns. Common approaches. You can define a write window. Say, data older than 1 hour gets rejected. That's simple, but might not be acceptable if, for example, a customer has a network partition and buffered data for 2 hours. A softer approach is to write late arriving data to a separate late data partition and have a reconciliation job that merges it into the main store on a delay. You accept higher query latency for historical data in exchange for keeping your hot write path clean. And the alerting path, you said there were two consumers. What does the alerting consumer look like? Right, so the second consumer is the alerting engine. It reads from Kafka and does real-time evaluation of alert rules against incoming metrics. The challenge here is that alert rules can be complex. Alert if the 95th percentile of request latency exceeds 200 mems for more than 3 consecutive minutes. That's a stateful, windowed computation. I'd use a stream processing framework here, something like Apache Flink or Kafka Streams. You define your alert rules as stateful streaming queries. Each rule maintains a window of recent values, evaluates the condition on new data, and fires an alert if the condition is met. How do you handle a scenario where FieldPath has 50,000 unique alert rules across all customers? That's a lot of state to maintain in a streaming job. That's a hard problem. 50,000 rules. You can't maintain all of those in a single Flink job, or at least you shouldn't. I'd think about partitioning the rule evaluation. You could shard rules by customer ID or by metric namespace, and have separate stream processing jobs per shard. That gives you horizontal scalability for the alerting tier. The other thing I'd think about is rule cardinality reduction. Most customers probably have similar rule patterns, and you could potentially share evaluation infrastructure for rules that operate on the same underlying metrics. But that gets complicated quickly. What about stateful recovery? If your stream processing job crashes and restarts, how do you reconstruct the window state? Flink has built-in checkpointing. It periodically snapshots the job state to durable storage, so on restart you recover from the last checkpoint. The downside is you might miss a few seconds of data between the checkpoint and the crash, but for alerting use cases, that's generally acceptable. You can tune checkpoint frequency based on your acceptable recovery time. Okay, last question. Where are your failure points in this design, and how do you handle them? Okay, failure points, the ingestion API tier. If that goes down, you lose incoming data. Mitigation, multiple availability zones, health checks, auto-scaling. Kafka. If Kafka loses a broker, you lose partition leaders temporarily. Mitigation, replication factor of 3, mean in-sync replicas of 2. The time series database, single point of failure if you have one cluster. Mitigation, read replicas for queries, primary replica replication for durability. Probably the hardest failure mode is a downstream slow consumer. If your storage consumer or alerting consumer falls behind, Kafka offsets grow, and you're accumulating lag. If the lag grows faster than you can consume, you eventually lose data when Kafka retention expires. That's a serious failure mode. You mitigate it by monitoring consumer lag aggressively, having auto-scaling on your consumers, and potentially increasing Kafka retention as a buffer. But ultimately, if a consumer is fundamentally too slow, you need to scale it. That's a decent answer. That was more than decent. Okay, I think we're almost at time. Jamie, really great discussion. Do you have any questions for us about the team or the work? Yeah, what does the actual day-to-day look like for this role? Like, is it mostly greenfield work, or is there a lot of maintaining existing systems? Mix of both, honestly. There's a significant amount of ongoing work keeping the existing pipeline healthy. We have customers who are very sensitive to reliability. But we're also actively rebuilding parts of the storage tier, which is exciting. That's been the main greenfield project for the last 6 months. And the team culture around technical decisions, is it mostly consensus, or does someone make the call? We debate, sometimes for too long. Then someone makes a call, usually Derek. That's a very Marcus way to describe it. I'd say we have good technical culture. People argue their positions pretty strongly, but it's not personal, and the best idea usually wins eventually. That's what I like to hear, honestly. Great. Okay, we'll let you go. Thanks for your time today, Jamie. Really enjoyed this. Yeah. Thank you both. I appreciate how thorough it was. Jamie, hey, I'm Derek. Come in, metaphorically. Thanks for making time. Of course. Okay, so I heard from Eleanor that you had a solid technical round. Marcus said, and I'm quoting here, decent. High praise. From Marcus, genuinely yes. He once described our principal engineer's architecture proposal as not actively bad, which was apparently a rave review. So anyway, I don't really want to do a formal interview with you. I kind of hate the format. What I'd rather do is just talk about work, about how you think, about what you care about. Is that okay? That's more than okay. Cool. So, first question, and I want you to really think about this rather than giving me a rehearsed answer. What does it mean to do good work? That's not where I expected to start. I know. Okay. I think good work means building something that does what it's supposed to do, reliably, and that other people can understand and build on. I've worked on code bases that technically functioned but were so opaque that nobody could safely change them, and I don't think that's good work, even if the outputs look fine. Good work leaves things better than you found them, or at least not worse. Interesting. The other people can build on it piece. Do you think that's a constraint or a feature? What do you mean? I mean, some engineers would say, look, I'm optimizing for the best solution to the problem at hand. If that solution is complex, that's the problem's fault, not mine. It's other people's job to keep up. Do you think that position is wrong? I think it's incomplete. Like, technically, the logic holds if you're a solo researcher or you're writing code that only you will ever touch. But most engineering happens in a social context, right? Other people depend on what you build. And I think if you're consistently producing things that others can't engage with, you're externalizing costs. You're making yourself look good by making everyone else's job harder. But isn't there a tension there? Sometimes the right solution is genuinely complex. You can't always simplify without losing correctness. Sure, yeah. I'm not saying everything should be simple. I'm saying the complexity should be necessary, not incidental. There's a difference between essential complexity, which is just the nature of the problem, and accidental complexity, which is complexity you introduce through choices. The goal is to minimize accidental complexity. You can't always help essential complexity. I like that. Okay, different question. Tell me about a time you were wrong. Not in a I made a mistake and here's what I learned way. I mean, tell me about a time you genuinely believed something strongly, argued for it, and then discovered you were actually wrong. What was that like? That's a harder question than it looks. Yeah, I know. Okay. About 2 years ago, I was part of a big architectural decision about whether to migrate our primary database from Postgres to a distributed SQL system. We were looking at CockroachDB specifically. I was pretty vocally in favor of it. I had done a lot of research. I had benchmarks. I had made a whole presentation. I was convinced it was the right move. And we did a more careful proof of concept and discovered that our specific query patterns, a lot of complex joins with subqueries, performed significantly worse on CockroachDB than on Postgres. Like, not marginally worse, noticeably worse in a way that would have impacted our product. How did you handle that? Honestly, my first instinct was to find reasons why the benchmark was flawed. I spent 2 days looking for ways to explain away the results, and then I kind of caught myself doing that and felt bad about it. Because I was doing motivated reasoning, I was trying to protect the argument rather than find the truth. And that's not useful. I had to go back to the team and say, look, I was wrong. The migration is not a good idea right now. That was uncomfortable, but I think I was a better engineer for doing it, and I think the team trusted me more afterward. Why more? You just failed to be right about something. Because it showed that I would tell them the truth even when it cost me something. That's more valuable than being right. Yeah, I agree with that. Okay, different direction. Why do you want to work at a startup? Because you could be at a big company. You have the skills for it. Fang would probably take you. Why here? I've thought about that, actually. I interviewed at a larger company about a year ago, got pretty far in the process, and what I noticed was every conversation was about a very narrow slice of a very large system. Nobody owned anything end to end, and I think I need that sense of ownership to do my best work. I want to make decisions that matter. I want to see the consequences of my choices directly. What if the consequences are bad? Then I want to learn from them directly. I don't want to be insulated from the consequences of my own decisions. That's how you actually get better. What do you think you're bad at? Is this the what's your greatest weakness question in disguise? It's not. I promise it's not. I'm asking what you actually think you're bad at, not what you've prepared to say you're bad at. I think I'm bad at letting go of my first solution once I've committed to it. Like, I get attached to approaches. I'll start building something, get invested in it, and then be reluctant to abandon it, even if I encounter evidence that it's not the best path. The cockroach DB thing is related to that. I have to actively work against that tendency in myself. I can be bad at asking for help. I'll sit with a problem for longer than I should because I don't want to look like I don't know something. I'm getting better at it, but it's still a pattern I catch in myself. That first one, the attachment to your first solution, how have you worked against it? I've started being more deliberate about writing down my assumptions when I start a design, so that when I revisit it, I can see whether those assumptions still hold rather than defending the conclusion. It's like leaving a note for my future self that says, "You believed X, has X changed?" And if X has changed, the design might need to change too. That's actually a great habit. Okay, last thing, and this is a genuine question, not a trick. What do you want to be doing in 5 years? I want to be doing work that I'm proud of on systems that matter. I'd like to have grown technically, gotten sharper on distributed systems, probably deeper into the infrastructure space. And I'd like to have made someone else's career better along the way, whether that's through mentorship or collaboration or just being the kind of colleague who makes the team stronger. I don't have a specific job title ambition. I know some people want to be a principal engineer by year X or a VP by year Y, and that's fine, but it's not how I think about it. I care more about the quality of the work. That's either a very mature answer or a very well-prepared answer. I can't always tell. Maybe a little of both. Fair enough? Okay, Jamie, I think we're good. Do you have questions for me? Yeah. What does success look like in this role in the first 6 months? Honestly, in the first 6 months, I want you to understand the system deeply enough to have real opinions about it. Like, not just, I've read the docs and I understand the architecture diagram. I mean, you've spent enough time in the codebase and talking to the team that you can say, this part is concerning, and here's why. That's success to me. You're not going to ship some massive feature in the first 6 months, and I don't expect you to. I want you to learn well and ask good questions. That's a healthier onboarding expectation than I've heard in a while. Yeah, I've seen what happens when you rush people and give them the message that they need to be fully productive in 30 days. You get a lot of bad decisions made by people who don't really understand what they're working with. I'd rather be patient up front. I really appreciate that. One more. What's the hardest thing about working here? Honestly, we move fast, and sometimes we move faster than our documentation or our processes can keep up with. Things are a bit scrappy in places. If you need everything to be polished and buttoned up, it can be frustrating. We're getting better at it, but I won't pretend it's solved. I can work with Scrappy as long as the intent is to improve. The intent is absolutely to improve. Okay? 上一 Really great talking to you, Jamie. I'll be in touch through Priya. Thank you, Derek. This was genuinely the best conversation I've had in an interview process in a while. Hi, Bar. Talk soon. Okay, sorry I'm late. Demo ran long. So, Jamie, what are we thinking? I want to start by saying I thought that was one of the better technical interviews I've participated in this cycle. Like, genuinely. It was fine. Fine? The coding question was fine. The system design was solid, but not exceptional. Marcus, they correctly identified the high cardinality problem without being prompted, walked through the trade-offs on stream processing for alerting, and handled the late arriving data question thoughtfully. What more are you looking for? I'm looking for someone who knows what they don't know. There were a couple of moments where Jamie filled in gaps with confident language rather than saying, I'm not sure, but here's how I'd approach finding out. Can you give me a specific example? The Flink checkpointing answer. It was technically correct, but it was book correct. It felt recited. I'd have been more interested in hearing, I haven't actually implemented this at scale, but here's how I'd investigate, rather than a textbook definition. Okay, but you asked a question, you got a correct answer. Are you docking points for sounding too prepared? I'm docking points for not knowing the limits of their own experience. At the senior level, I expect people to distinguish between I know this and I know about this. That's a fair distinction. Did it come up more than once? Once clearly, once maybe. The Kafka retention recommendation, the increase retention as a buffer answer. That's naive if you're at that scale. Kafka retention costs money, and using it as a primary mitigation for consumer lag is not a real strategy. They said that was a buffer while you scale the consumers, not the permanent solution. They said it in a list. It wasn't emphasized as a stopgap. It came across like a real recommendation. Okay, but you're not recommending a no hire on the basis of one possibly ambiguous answer, and one answer that was technically correct but sounded rehearsed. I'm recommending we think carefully. Marcus, look, I respect your technical standards, and you know I think you push candidates appropriately, but I also think there's a pattern where we sometimes reject strong candidates because they don't present exactly the way you'd present. Jamie is 8 years in, has production experience that directly maps to what we're building, showed genuine intellectual curiosity, and recovered really well when you made them doubt their correct answer. I made them doubt their answer to see how they'd handle pressure. That's the point. And they handled it fine. They went back through the logic, verified it, stood by it. That's good under pressure. It took them almost a full minute. 30 seconds. And they were thinking. That's what you want someone to do when they're under pressure. Okay, Eleanor, you're a yes? Strong yes, I'd want to work with Jamie. Marcus? I want to think about it. That's not an answer I can use in this meeting. Strong no, lean yes, strong yes. Lean yes with reservations. What would it take to move those reservations? The first 6 months will tell you everything. Either they grow into the role or they don't. I don't think we'll know from this interview. That's true of basically any hire. Most hires don't have a gap between their confidence and their depth. When that gap exists, the first 6 months are make or break. Okay, that's a fair observation. I want to add my read from the culture conversation. How did it go? Really well, honestly. The thing that stood out to me was the answer about being wrong. I asked about a time Jamie genuinely believed something and then discovered they were wrong. A lot of candidates do the standard, I made a mistake, and here's my growth story. Jamie actually talked about catching themselves doing motivated reasoning in real time. That's a level of self-awareness that I don't see often. That could be a rehearsed answer too. Everything could be a rehearsed answer. That's not a useful filter at this point. What I look for in that question is whether the person sounds like they've actually experienced the discomfort of being wrong, or whether they're just describing it from the outside. Jamie sounded like they'd actually felt it. And the rest of the conversation? Good, smart. Answered the "what do you want in 5 years" question without giving me a title ladder, which I appreciated. Said they wanted to make someone else's career better along the way. That's not something you say unless you've actually thought about it. Or unless you've read enough interview prep articles. Marcus, come on. Fair. So where are you, Derek? I'm a yes. I'm a genuine yes. I think Jamie has the technical chops, and before you argue, Marcus, lean yes is a yes. It just has an asterisk. And I think the self-awareness and the communication style are going to make Jamie an asset to the team. The gap between confidence and depth that you're worried about is something that either closes fast when someone is in a high-quality environment, or it doesn't. And I think we're a high-quality enough environment to close it. If it doesn't close, then we have a real conversation. But I'm not going to make a hiring decision based on a fear that 6 months from now might not go well. I've hired on that basis before, and I've passed on people on that basis before, and the passes have cost us more than the hires. Okay, I'm not going to block it. That's the warmest endorsement I've ever heard from you. I said what I said. All right, I'll have Priya put together the offer. Standard package, top of the band. I'd rather not negotiate on this one. I think it sends the right signal about how we value the role. I'll also make sure there's a note in the onboarding plan about pairing Jamie with someone solid in the first month. Marcus, would you be willing to do a few pairing sessions in the first 6 weeks? Yes. Good. That's actually the best thing you can do with your reservations. Put them to work. If there's a gap, you'll help close it. That was very wise of Derek to just do that. I'm right here, Eleanor. I know, I'm talking about you. All right, good work, both of you. I think Jamie's going to be good for this team. Let's get the offer out by end of week.
Thanks for watching. Subscribe and give a thumbs up. See you next time.